I am so excited about tonight's show, and as you know, we had some experiments that went on attempting to perfect the cocktail this time. We did it a couple different ways. I just have a few announcements, and then we're going to get rocking and rolling. We now have a Facebook page. I caved to pressure, so we do have one now, and that means we can actually have our discussions sort of before and after the show, and that means you can also continue the discussions that happen in the chat here over there on Facebook as well as on our Twitter feed. So tonight is a very special show because one of my favorite authors is on, Carl Zimmer, and we're going to be talking about Life's Edge, which has so many fun features. I hope you guys have great questions. I have great questions. Davey, what do you have for us?
Oh man, I am excited to talk about this book. There are so many, it's such a sprawling book. There are so many topics. Once again, you have challenged me to dig into pop culture and movies and TV and come up with a quiz for Carl tonight. And Carl, I promise there's no trick questions in this quiz. It's pretty straightforward, but I think you're going to want to stick around for the end because I call this quiz ribonucleic answers. So that gives you a little hint what our quiz is going to be about tonight. But I'm very excited to hear all of your questions out there and hear what Carl has to say.
Yes, this is great. And welcome, Carl Zimmer.
Hello. Thanks for having me.
We're so excited you could be with us. I have to say that Life's Edge is, I actually was listening to it on the treadmill while I run because I like audiobooks. I have the hardback as well. But at least once, I almost fell off the treadmill because I stopped running. I was like, what? And then, boom. So it's really been exciting, and I am thrilled to know all of the details that went into this. But before we get started, I have to sort of introduce our excellent cocktail that sort of is trying to make sense of some of the things that Carl talks about in the book, particularly related to organoids, which are my favorite. So I'm afraid that Thing had the night off tonight, everyone, so I had to... Oh, thank you. Instead, we had to go with Lurch. So this is the cocktail that I've been talking about, the cocktail I've been dreaming of in some ways. This is for you, Carl. I wish I could hand it through the screen. We've started off, I haven't yet done the magical experiment that changes it. I do have the boba down in the bottom to serve as our little organoids. My helper needs to come, helper, come, Lurch. Yes. So we can light it up and sort of see what's going on in there.
Very nice.
But right now it's blue, and the magic of this cocktail, of course, is that you add the lemon juice, and because it's butterfly pea flower, it performs a little bit of a magic trick. So we've got some simple syrup and some lemon juice, and slowly it turns a luscious color of purple. Ooh. And it's a mixture, really, of blue and purple. Ta-da! And we encouraged everyone to come up with some fun cocktail names. What a list we had. And Carl had to make a very difficult choice. Carl, what was your choice for the name of this cocktail?
There were a bunch of very good ones. Primordial Booze.
Primordial Booze. So if you are the person who gave us Primordial Booze, I'll be in touch with you later, and you can also email or text me. But we are so excited that we now have a fancy name for our cocktail, which is pretty good. So setting that to one side. I did make this earlier, and getting the bobas out was a little bit of a difficult task. So I was attempting to use the big straws. You should not drink vodka that fast. I just want to say it's not really recommended. So it's very exciting.
Sounds like
I see several people have had some experiments of their own.
Oh, wow. All right.
Lemonade with butterfly pea gin sounds good. So I wanted to start the night by asking, I think, my favorite question, which is always kind of related to titles. What gave you the idea to call it Life's Edge? Because I think there's so many things going on in this book. You know, what really drew you to that as a title for the whole?
Well, I was reading a lot about these scientists who were trying to figure out what life is, over the past few centuries, and they would sort of end up in this weird sort of borderland between the living and the non-living, and they were I felt like they were searching for life's edge, like, can I find something or make something that's just barely alive that kind of helps me to see where that edge is? Yeah. And it was really dangerous. I mean, because people's careers would be destroyed often when they tried to do this. And so rather than like there is this sort of classic question of what is life, right. But I wanted to think of life more as a kingdom or a territory, and that there's this edge around it, and maybe that we think of that edge as like, when our lives begin or when we die, or maybe there's that edge 4 billion years ago when life began, or maybe it's just an edge where we're just thinking, about the space of possibilities, and there's sort of a space of life, and beyond it, it's not life. So what is that edge?
I love that. And I actually said that in one of my tweets. I was like, the edge between life and not life, because it's not quite death, is it? You've got things like tardigrades and other creatures that kind of seem alive, but then they look like they're dead for ages and ages. And then you put them in water and they're like, no, psych, here I am. So I think that's fascinating. My preview to this, and I did put this up online, was your comment about brain organoids. And I want to ask a question. I'm trying to figure out how to phrase this delicately, and I'm hoping you guys are typing in some questions related to this. But you were talking about how if we think about skin cells that you can turn into brain cells as living things, it can get really sort of crazy, can't it? Because then does that mean all of your skin cells are potential people? And you brought up that sort of life begins at conception concept that has been sort of hotly debated over the last couple of decades. And I know that's really dangerous territory to sort of wander into as a writer, but it was a really great question. What happens if you think of your skin cells as potential people? I mean, that's a very strange way of being a parent.
Yeah, well, I mean, I think, we part of the problem with grappling with life's edge is that we kind of think of it as being completely fixed. Like it's this sort of almost, mathematical rule about where the edge of life is. But we ourselves change the edge. So with death, for example, like when do we die? When does a doctor declare someone dead? Well, that was the answer was very different in 1950 than today. I mean, right. Once you have ventilators that keep people's bodies going while their brain is gone, then you're saying like, oh, wait a minute, I need to redefine life and death now. So now death
actually, and that leads us, this is a great question by Kristen Meston, which I'll pop up there. And I think this is the heart of it, isn't it? What is the purpose of definitively defining life? Could scientists and philosophers resolve to be satisfied with just never having a final definition?
So, I mean, that's a great question. I mean, certainly, just sort of like as someone who is writing about sort of the history of life and our study of life. I mean, the fact is people have been trying to define it for centuries. And I'd argue that they've failed in the sense that nobody agrees on definition. You can find hundreds of definitions in scientific literature. And in the book, I talk about how there are some scientists and philosophers who say, this is just stupid. Like, we need to stop trying. We need to stop.
Yeah.
We need to resist the urge to define life, because it's getting in our way of really a deep understanding of life, which people will say like, whoa, how could that be? But like, think of an alchemist in 1500, and ask them to define water. Like, that's not really going to get us anywhere in 1500. Well, what people need to do is develop a theory of chemistry and molecules and atoms and so on. And then all of a sudden water just kind of makes sense.
So we almost haven't gone wide enough in our search, maybe. And so this is partly but that gets back to your concept about the borders and the boundaries. Obviously, I was really impressed with this book because I just finished a book called Mr. Humble and Dr. Butcher, in which the titular character, Robert White, who those were his two nicknames, keeps a brain alive outside of a body, and it still sends out thinking waves. It's still, sending out brain waves. It's thinking of some sort. And so when I was reading about your brain organoids, I was like, yes, that too. What happens? We can say brain death is when there's an isoelectric signal, but what about brain life? Like, where does it? It's almost like the start might even be more difficult to define than the end.
Right, because like if you were to imagine one of my skin cells, sort of deep down in there, the epithelial cells, it's alive in the sense that, like, it's metabolizing, its genes are making proteins, it's getting rid of waste and so on. It's doing a lot of the things that living things do. And we could take that cell and put it in a dish and give it food. Now it's not part of my body anymore, but it's still doing its thing. Now you hit it with some chemicals, you can reprogram it. So essentially it's like kind of like a stem cell in an embryo. Hit it with some more chemicals, you start letting it grow and divide and develop as neurons that you would find in the brain of a developing embryo. Now, it's not going to end up looking like a full-blown, like, sort of, brain in a vat. It's not a brain in a vat, but I've gone to the labs where they grow these things, and okay, it's not a brain in a vat, but it is like a pea in a dish. It's there, and yeah, right, yeah. So they can get to be about, these brain organoids get to be about that big. They can be like 1 million neurons. They're organized. They have a sort of an organization kind of like the cortex, and they're layered. They have lots of different kinds of neurons that you find in the brain. This all developed from one skin cell. Okay,
one single skin cell.
One single skin cell. So these things produce what look a lot like brain waves. They resemble a lot like fetal brain waves, actually.
That's
so, what have we done? What have we made? I mean, scientists are figuring that out. I mean, they did it for a very practical purpose. Like, they want to study diseases of development of the brain.
Sure.
Really serious diseases, development of the, yeah. So that's their goal, but they have sort of realized along the way, they've said, like, okay, like, how are we going to know if one of these things becomes conscious?
Right. And the consciousness thing is, I think that's one of the more fascinating. I'm just popped up Joanne's question here regarding people in the skin. The octopus has neurons up and down its arms. And yet we don't know where the seat of its intelligence is. And we agree. So I thought of octopi too, when you were talking about skin cells, because I thought, I know we have neurons in our gut, but we don't normally think of our gut as, well, some people probably do, but we don't think of our fingers and hands as separate brains. And yet with something like an octopus, which we,
Oh, yeah. No. And octopus's tentacles are like definitely like mini brains. I mean, your skin, a skin cell, I would say is not. I mean, a human skin cell can't compare to what's going on in an octopus's tentacle. But what's strange is that every cell, for the most part, has the same entire human genome. And it just sort of depends on where and when it's using its genome and which genes it's using. So you can use that genome to make a skin cell, but you can basically it's like, giving an orchestra like different sheet music. Like you can then, that same cell can then actually give rise to a brain, because all the same genes are in there.
Right. Which is fascinating to me, because you just think about it. In my head, prior to writing the brain book, which now my mind is blown by all of these things, but prior to writing that, I would have thought each cell had some totally different instructions, but instead they all have basically the map. I just want to throw several people were trying to come up with other ways of thinking. So perhaps life is a condition rather than a category, or maybe when does biological matter become life is a better question. I think that's an interesting one. Or even what makes life worth living. And that seems to get back to consciousness again. And all of those are really excellent questions. Susan Ballinger added, but then that means who gets to say what's worth living and what isn't. And so, you made a really interesting point when you were talking about the organoids. You said, if these end up being things with consciousness, then we have to take care of them. Like, what do we owe them? Yep. And I think that's a fascinating question. It didn't seem like there were real answers in some ways, just lots and lots of questions.
Yeah, I mean, this is a book that is, if you're looking for definitive answers, look elsewhere. This is a book full of questions and questions that, a lot of which are old, but some of which are very new, like with these brain organoids. We just didn't know. These things have only been created in the past few years.
Yeah. And then they've gone to space. They sent them to space. Am I right about that?
Yep. Yeah.
They have more interesting lives than I do.
It's true. Yeah. So some scientists decide we're one of the challenges with these brain organoids for these scientists is they're like, okay, they get to be this big, and then they kind of stay there, and they'll stay like that for years. How can we make them bigger? And so maybe gravity is holding them back. So they sent some up in this recently to the space station and grew them, and then they've come down, and now they're studying them to try to figure that out. 0G mini brains. That's pretty wild to consider.
I just love it because it makes me wonder what my brain would do in zero gravity. It also makes me wonder if maybe I could build myself a second brain, because I feel like I could use one. 2 brains. I could write books twice as fast. Think about how good that would be, Carl.
I've often wished for a second brain somewhere around.
I want to get to Sadie Simon's comment. Did working on Life's Edge change your end of life planning or the conversations you have about it with your family? Which I think is a great question.
Yeah, that is a great question. I think, so the thing is that, these technologies like iron lungs and ventilators and so on, I think that they might. It's important to sort of understand what they can and can't do. I mean, they can give some badly injured people the opportunity to rebound and recover, but for the vast majority of people, it's really only going to keep them alive for a short period of time, and it's a life that is really not the life of that we think of as a human life, in the sense that it's not. It
doesn't have consciousness largely too, right? For a lot of these.
Yeah. Now, if you're going to have a strict definition of life, I mean, the fact that people can use a ventilator, it tells you a lot about what's going on in their bodies, their lungs, their circulatory systems. There's homeostasis going on, for example.
Right.
Their bodies are balancing themselves and keeping themselves stable. So that's really significant for life, sort of broadly defined. But, we really need to ask ourselves, well, what is our life? Is our life just our cells maintaining their inner chemistry, or is it about integrating our experiences in our brains? And, the fact is that, when a brain is badly damaged, that's it. On the other hand, I do, there are other cases I don't go into as much in the book, but I've written about elsewhere where, there are situations where people have brain injuries that leave them locked in. Now they appear maybe appear no different than someone on a ventilator, but in fact, things are, all the lights are on in
right.
the
Well, and that's in itself, of course, with the book I worked on, the question was, when do you transplant organs, right?
Mhm.
So when are you dead enough for somebody to take your organ, but living enough for your organs to be useful? Right. It's tricky because it becomes a legal question almost, rather than a biological question. You brought that up about Jockey McMath in the book too, about how some questions are medical questions, some questions are philosophical questions, but a lot of times it comes down to a legal answer. It comes down to a court case of some kind.
Yeah, well, the case of Jockey McMath is really remarkable. There's a wonderful article in the New Yorker by Rachel Aviv where she really went in deep on Jockey's case. But the thing with Jockey McMath, the basic story is that she had to be put on a ventilator after she had surgery that went bad, and there was and her family did not want her to be taken off the ventilator. They're like, no, we want you to keep her on the ventilator. They were just convinced that she would. Well, they would say like she's still alive, and there was this idea that she was still in there. And the fact is that the vast majority of cases with people who have this serious brain damage or are on ventilators, like they will die in a pretty short period of time. Just complete, like everything will give out.
But she was like a strange case because we said a question here, locked in. She was talking about as in awakening.
Yeah, she was. She was not locked in the sense that like people who are locked in, they can talk to you by blinking. If you give them electrodes, there are ways to sort of get in there and sort of get full blown communication. There was never any really clear, compelling evidence that she could still communicate. But that does not take away from the fact that her body did not fail in a week.
Right. She even went through puberty, you said, which is something you normally associate with a living creature rather than something that has died. I mean, we think of that's growth, not decay, really.
Exactly. And the process of puberty is a very complex process, which is regulated in part by the brain, the fact is that a lot of systems in her body were continuing for several years. Sadly, eventually she did die, and she was still a teenager. But it was I believe it was of liver failure. So it was separate from the immediate cause of her going on the ventilator.
She basically has two death certificates. Then she has a brain death certificate and a whole death experience.
Yeah, because she had to be put on the ventilator in the state of California, and they have their rules there, and they declared her dead. And then her mother found out that in New Jersey there are these exceptions for religion, and so she ended up being flown to New Jersey, where her mother took care of her in a little apartment for a couple of years. Yeah. And then when her heart stopped, her lungs failed. The people in New Jersey gave her a second death certificate.
Right. It's a fascinating story. I just saw a question pop up, which I know this is a little bit off this particular topic, but it's a good one, which is talking about things that aren't human and where the line between life and death are. So Daniel asked, virus, dead, alive, or just a dead device that hijacks life for its own purposes? I certainly couldn't answer. What do you think? Where would you sit on that, Carl?
Oh, yeah. Well, this is one of these questions I love. I actually have most of a chapter dedicated to this in Life's Edge because viruses have vexed scientists on this score for ever since they were discovered in the late 1800s. Because the more that scientists found out about them, the more puzzling they were, because it is true that they lack some of the things that we consider like hallmarks of life, like metabolism, for example. Don't have it. But, on the other hand, they have some hallmarks that are really important, like evolution, for example. Like you couldn't ask for more, spectacular effective evolution, then, well, I don't know, the Delta variant.
Right. We're dealing with right now.
Yeah, the Delta variant is a product of evolution and is just completely paralyzing human civilization. And, that was the product of evolution. So, if there's something that's not alive that is evolving in such a spectacular way, well, what word do we use for it? I don't think dead would work. I don't think I don't think that fits in. I think our language is very impoverished when it comes to trying to describe things that are at that edge of life, like viruses.
Right. A couple of people asking about prions, and are they alive, or is this a protein that's just been misfolded?
Well, I mean, a prion is a misfolded protein, but you could also say that you and I are just, bags of protein and water and lipids. I mean, that is the chemistry of a prion. But when we talk about life, a lot of what we're interested is what's happening, what it's doing. And, prions really, again, they do challenge our ideas. Prions are like, so just to remind people about prions. So like, if maybe you've heard of mad cow disease or something like that. So you can get that by eating infected, beef from infected cows or sheep. There's a disease called scabies that is related. Anyway, so you have a protein that's deformed, and if it goes up to the same kind of protein and grabs onto it, it can deform that as well. And now that deformed protein then goes off and deforms another one, and that can just radiate through a host and then spread to another one. Deer right now are being devastated by a prion disease called chronic wasting disease.
Oh yeah, the zombie deer disease.
Yep.
That's terrifying.
It is totally terrifying. Yeah. And these prions, the deer will shed them. And, again,
disease in urine and all that other kind of stuff.
Yeah. And these are just proteins which are pretty rugged. And so they can just stay, they'll just stay on the forest floor for weeks or months, and then other deer can pick it up.
Right. If
some
you guys
people
aren't aware of why it's called zombie deer syndrome, there's some really terrifying videos. Don't watch them before bed.
Yeah. And along with the zombie theme, some scientists I talk to, I'll say like, well, how are you going to control this as it continues to spread across North America? And they said because it's so durable on the forest floor, like maybe fire. Maybe fire is
the only way. I mean, we had Lindsay Fitzharris on our last show, and the joke was during Lister's time, you just burned the hospitals down periodically to get rid of the germs. And so there is we have a history of suggesting fire as a pest.
Yeah, but now we're saying that in the 21st century because these prions are so hard to deal with. So, but are they alive? Well, they've got less of what we consider life than viruses, I would say.
Right.
But still, they can still do that sort of basic replication, or at least at least creating more copies of themselves from other proteins.
Right. Piggybacking on that, Allison asks, what would be the argument about viroids? What do you think about that?
Yeah. So viroids, so viruses are a package of genes inside of a protein shell, and that shell fuses to one of your cells and dumps in the genes, and then that cell makes more viruses. Viroids are these bizarro things. It's just a string of naked RNA. It's incredibly short, and it has no protein shell. You'd think something like this could not survive in the world. And yet they are like a major pest of many crops. There are viroids of coconut.
Keep all of our maybe not alive things straight here.
Yeah, right. I know. There are viroids of coconut trees. There are viroids of chrysanthemums. There are all these viroids that are adapted to different plants, just plants as far as we know. So it may have spun off of a plant and become the ultimate parasite. It's hard to know. but yeah, like, I mean, so it's kind of a virus in its purest form, you know, because it's just a naked, it's a naked piece of genetic material. That's it. And
I keep thinking of zombie movies. Now I'm thinking of The Girl with All the Gifts with the it's a zombie film where in the end it's the pod of the tree that's spreading all the zombie pollen everywhere. I did see someone. This isn't really a question. It's just a comment that they appreciated that you seem to have some impressions about some of the way these things were going to be moving along, whether we want to believe it or not. There was a question from earlier, since we were just talking about nature, and now I got to go back and find it, about your wanderings in caves and bats. And I love this too because I'm a big fan of bats. Abby, where is that question at? There it is. So what was it like spelunking for bats, and what did you learn? I do think that that's a fascinating part of the story, and I ended up asking this question on Facebook. Actually, I tossed it in there that, you know, you just gave us a chapter on slime mold and how instead of being completely creeped out by another zombie creature, we should respect it. And then you give us a chapter on how fungus is destroying this bat population, and I feel like you're playing both sides. What was it like? How did you feel about all that?
Oh, it was wonderful, because, you know, I'm used to, you know, seeing bats just zipping by, you know, at twilight. That's my image of a bat. But the fact is that in, you know, places like where I live in Connecticut or New England or you know, Canada, like, you know, like these bats, which are like just, you know, have this incredible metabolism and high energy all summer long, just gathering up insects. They have to survive through the winter. And the strategy they've chosen is not quite dying, but something kind of like it, in the sense that they go into a cave or an abandoned mine, and they just shut everything down.
Yeah.
And they will be there for months in this hibernating. And so, you know, to see a hibernating bat is not an easy thing, and it's especially hard these days, thanks to white nose syndrome, because bats are being decimated in the Northeast and other parts of the U.S. But some New York State wildlife biologists said, yeah, come along. And so we went to the Adirondacks to an abandoned graphite mine that they go and visit every year and count bats. And, if, you know, it's one thing to go into a cave where, like, you know, a cave has kind of been there for a long time. This was a mine that had been abandoned. It was, they got graphite out of it in the 1800s. And then the graphite market in the US fell through, so they abandoned it. The bats didn't, and so, you know, we're going in there, and it's kind of falling apart. You know? So it's just
don't touch anything; it might fall down. Like, that is not what you want to hear when you're underground with bats.
No, yeah, and you know, there's this big stream of cold winter water going through it. We're in these neoprene waders, and
First of all, I have to ask you questions about your choice of friend groups here. I mean, like, I need to go count some bats, and you know who to call. I mean, like, how did you run it? I mean, Carl, this is research, but also my research. Well, that's not true. I was in the catacombs, so it does happen sometimes. But, you know, how did you just know? Like, I'm just going to call up, and we're going to see if we can go count some bats today.
Well, you know, these wildlife biologists, I have to say, are pretty, they're pretty media savvy or media experienced, in the sense that, like, these are the scientists who have been trying to tell the world about white nose syndrome, this fungus that was brought to North America from Europe and is just raging through bat populations. And it's a disease. You know, what's interesting for my book is that it's a disease of homeostasis. You know, the thing is that the bats can't stay in their hibernating state all winter long because of this fungus. This fungus wakes them up in the middle of winter because they have to spend so much energy over the winter fighting it off. It's a cold-loving fungus, which, like, is as if it wasn't evil enough. This is a fungus It's a fungus. It doesn't like to grow when it's warm, but when it gets cold, then it just takes off. So, so they want everyone to know that, you know, our bats are really in a desperate state, and this is an
So
emergency.
when you called them up, they weren't like, no way. They were more like, here's some waiters.
Yeah. They were like, yeah, here are a list of dates. Here are the things you should bring. Yeah, we're looking.
What was on the list? I'm just curious. I mean, not being somebody who typically spelunks in the middle of winter looking for bats.
Well, the neoprene waders are really important because otherwise you'll freeze to death. But you know, snowshoes help because like you have to like go from the truck to the mine, and there might be like several feet of snow that have fallen because it's all done in the winter. Yeah, these are pretty badass biologists, I have to say.
I think most biologists can be. We might as well talk about snakes.
Sure.
I like snakes. Snakes are good. I don't have a pet snake. I did. So when I was young, I lived underground, which I don't recommend. And we did, the only thing above ground was our roof. And we had a black snake that lived in the roof. So she actually had the penthouse. And that was our snake, sort of to keep away mice, because we had a terrible mouse problem living in the ground, which is where the mouse are from. So for me, I have a positive relationship to snakes, even though I never had one as a pet officially. I more feel like we were her downstairs tenants. But you know, I mean, how do you feel about snakes? I mean, did you go in and go like, yeah, snakes, or were you like, this is my least favorite part of this book?
Yeah, it's interesting that a lot of people have a real just phobia of snakes. You know, I find them beautiful animals, you know, and so for the book, I went and hung out with a snake biologist and his friend, who calls himself a snaker. He just keeps a lot of really big snakes at his house, and you know, in these various containers, and it was great to be holding these gigantic animals, but they're just beautiful and so on. But you know, like the snaker whose snakes they were, like he did just, you know, keep reminding me like, yeah, you do have to bear in mind like they could kill you, you know. So you know, we were always like keeping an eye on them. They're, you know, they'd much rather like kill a rat
Right.
than kill us, you know. So it's okay. And they're just such magnificent animals, and you know, and for me, what was really fascinating is the talking about the hallmarks of life. You know, metabolism, I mentioned before, that's key. And you know, if you're looking for extreme metabolism, you know, you got to go for these boa constrictors, these reticulated pythons that can, you know, just swallow gigantic animals and then suddenly like digest them over the course of a couple of days.
Yeah,
it's a metabolic marvel.
I've seen the photographs of things eating, you know, alligators or whatever. And the fact that you said that they basically are able to turn their biology on and off. And I guess that's kind of what the bats are doing. And in a way, that's also just that gets us back to, you know, where the edges of life actually are. Because if you're able to turn your biology on and off, where do you, I mean, tardigrades, how is that a living thing?
Right. So tardigrades, you know, they're all over the place. You know, they're in the soil, they're in the water, they're everywhere, and they're these adorable little animals. They
look like bears, kind of.
Yeah, they're sort of nicknamed water bears. They have 8 legs, these little kind of bear-shaped legs. Their face is not really a bear's face. It's basically no eyes and like a giant kind of like trumpet for a mouth. It's really kind of nightmarish, but otherwise very cute. And so what they're known for is that if you let them just desiccate, dry out, they respond in this amazing way. Like if we start losing our water, we die. I mean, it doesn't take losing much water for us to just totally check out, because you know, our metabolism just stops working. We need water as a solvent. But with tardigrades, they respond in this marvelous way. They make all sorts of new chemicals that allow them to sort of replace the water that's evaporating. And then ultimately what they do is they end up sort of creating a kind of a glass-like proteins that basically they vitrify themselves. They essentially turn themselves into glass. Everything gets locked in place.
Amazing.
Their DNA, their cell membranes, all of it frozen. They do it to themselves. And they can stay like that for decades, maybe centuries. You can send them into outer space and bring them back. And if you put water on them, that water basically like triggers them to get rid of all that glass-like protein, restore their cells again with water, and they just waddle off as if nothing had happened. So, people will refer to this sort of living glass that they become as a kind of as a third state between life and death. They're not alive, because if metabolism is essential for life, like they can't do it. So people have called this cryptobiosis, which is a lovely, lovely word.
But if there's no water ever again, then there's no tardigrade ever again, right? Water is crucial for this?
That's true. That's true. Yeah. So
I just mentioned it because you talk about if one's sitting on the moon, crash landed on the moon somewhere, and there's no water.
Yeah. There was this crazy project where some people decided to send this little sort of package of various things from Earth to the moon, and it included a little container of tardigrades, and the thing just crashed into the moon, and so. So it's interesting to sort of speculate that there are these cryptobiotic tardigrades just sitting there on the moon. Yes, I mean it's likely that no water will come.
An astronaut's going to drop his water bottle someday, and there's just going to be this bloom.
Yeah. Right, but maybe an astronaut would come along and say like, oh my gosh, this is that crazy thing that people sent to the moon. I found it, and so let me scoop up these tardigrades and bring them into the moon base and put them in water and see what happens. I would bet they might come back to life.
Probably come back to life. That's so interesting. Kristen asks, do you have an opinion on volcanic pool versus ocean vent? Based on your research, it seems like you were leaning towards volcano. Volcano. This is Carl versus the volcano.
Yeah. So it's there, when we talk about the life's edge, one of the most contested ones is that edge through time, like from before there was no life on Earth, right. and then there was life. So what was it like for chemistry to cross that edge, and where did that happen? And so I wrote a lot about one scientist named Davey Berris, who for decades has been championing and testing this idea that life started in ponds on little volcanic islands 4 billion years ago or so. And he argues that that these ponds were sort of these sort of chemical engines that could generate all the molecules you need for life. Okay. There are a bunch of scientists who think, well, no, actually, it's the vents where it would have happened. I think there are a few points where the volcanic argument is more convincing, just in the sense that it's kind of hard to see how the whole process happens in these deep sea vents. But it could be, could be both, in the sense that there are, when we think about other places in the solar system where life might have begun, there's Mars, and, Perseverance is there looking for fossils right now, which is incredibly exciting. But then there's also these icy moons, like Enceladus, where you have a big, thick layer of ice, and inside you have a liquid ocean. And so there's no volcanic islands basking in the sunlight where you're going to have a life start. But you do probably have these deep sea vents,
right,
on these in these moons, and so maybe life is in the process of starting there.
Right. A fun conversation has been happening in the chats over here about we're going to forget that the tardigrades were sent there by people, and someday we're going to find tardigrades on the moon, and people are going to be like, "Oh my gosh, there used to be water on the moon." It does. We watch all these programs about accidental seedings of life by alien life forms, and now it sort of seems like we might be doing that ourselves.
Yeah, we may have sent a fair amount of stuff to Mars already.
That's true.
And so if we find microbes on Mars, we do have to be really careful to make sure that they weren't ones that
turned up on something that
piggybacked on Viking or something.
Well, because back to the weird edges of life, microbes are one of those weird things that tend to live and should die but don't when you send them places. Getting a little bit more philosophic here, do you think consciousness exists outside of the physical body? And one caveat, of course, from my work is that if you take the brain out of a body and the brain's still alive, then technically that's existing outside the physical body. Dr. White does that. But I know what you mean. There's a new book coming out about how like thinking beyond body or something like that. Like how do you feel about that, Carl?
Right. I think you're thinking of Annie Murphy Paul's book. And I mean, Annie is thinking about our thought processes that happen in the brain as being, part of a broader reality. That they're, our brains are embodied.
Right.
That they experience the world through our bodies, and that there is sort of a looping back and forth between our own thoughts and the world around us and our own bodies. It's really fascinating. I highly recommend people read it. I don't think we really understand consciousness well enough to answer that particular question that the viewer asked, because we know consciousness. It's kind of like life,
it's one of those tricky ones, isn't it?
Right. We know life here on Earth. So then when we say like, oh, I wonder if there's life elsewhere in the universe, we can only kind of conceive of it as we know it here. And life here is in some ways kind of boring, in the sense that it's like there's just everything got DNA, they've got ribosomes, it's all kind of standard. So with consciousness, we're like, well, what's consciousness? Well, I know what consciousness is because like I'm talking to you and I know who I am. So I've got that. And then like everything else is kind of a bit speculative. So there are theories that kind of try to kind of step outside of our own subjective experiences. So one of them is an information integration theory that people like Christoph Koch and Giulio Tononi at the University of Wisconsin have developed. And there they think that it's just a matter of how information is integrated in a complex system. So it doesn't have to be a brain. It could be a cell. So like cells can have a certain amount of consciousness. Bacteria can be conscious to a certain extent. Right. So maybe, you could argue that some sort of artificial system could be conscious as well, just as long as the information in it is integrated in a particular way, which is what is cool about this theory is you can measure it.
Right.
Like, they're doing these experiments where they're like, okay, we can tell you if this person is conscious or not as anesthesia kicks in by measuring the integration of information in their brain.
I find this fascinating, and I see everybody's really excited about. Everyone's talking about how much they are enjoying this, and how much they're glad that they're here, and that this is just a fun conversation, which I completely agree. I don't want to slow us down at all. However, I do want us to get over to Davey Berris, who's got some fun questions for Carl. So let's do that, and then if we have time, we'll come back and do some more. But it's been really fun. Davey, take it away.
Hey, all right, great to be back. So, I mean, I feel like you guys are having such a high-level conversation, and I am about to bring it so far down with some of these pop culture references, and we've referenced movies and zombies and things like that. throughout the conversation. But there's so many things, Carl, in your book that just popped to me. And I guess I kind of got hung up at the end of the book because we end with such a conversation on RNA and lipids and stuff like that. So bioscience was kind of on the front of my mind as I was finishing up the book. And I found a great article about the 15 best biotech movies and TV series to enjoy this summer.
Okay.
And as you can imagine, a lot of them are about humans doing things they probably shouldn't be doing. And one of them was Gattaca. I thought was a fun one where they're actually selecting things for their children, predetermining things for their children. There's another one, interesting one here called Blueprint, which is about someone who has a terminal illness and then clones themselves so that their art can live on. Which is an interesting concept. And then you have virus movies like Andromeda Strain and stuff like that. So that was interesting. If I want to bring it down even further, sometimes it's the movies for kids that just explain things the best. And I couldn't help but think when you were talking about the cells in the body and how they work, I couldn't think there was a movie from 2001 called Osmosis Jones, voiced by Chris Rock. And it's like the perfect movie for when you were a kid to understand white blood cells and how they attack a virus. And it's so silly, but sometimes it's the comedies, sometimes it's the movies for kids that just explain things the best. There's a new one out now. In fact, Pixar's Soul, which came to mind as I was reading your book, which I'm excited to see. I haven't watched it yet because if I put that movie on, my dog would go crazy barking at the screen. And then, of course, the chapter on snakes. You guys already talked about it, but the snake digestion. If that got you in the mood for a snake movie, I gotta recommend Anaconda from 1997.
Pretty classic.
Lopez, John Voight. If you are into snake digestion and that chapter really got you excited, there's a good movie for you out there. So I mean, your book covered so many different topics and so many different things that it brought so many of these things to mind. And we like to play a little game with our authors and challenge you a little bit. So we do a little quiz. And this one, I thought of so many different things. And what I was really hoping to find were myths about life that were proved false, but from ancient civilizations or things like that. But my Google searches did not turn up what I was hoping for. So instead, I decided to focus on RNA because it was such a huge part of that kind of the second half of the book or the last third of the book. So we call this ribonucleic answers. And I'm going to flip us around so everybody could see you. So the first question here, Carl, for you. Which of the following is not a type of RNA? That be A, transfer RNA, B, midichlorian RNA, or C, messenger RNA?
Well, I'm definitely least familiar with the midichlorian RNA. So
that is correct. That would be from Star Wars.
There you go.
Yeah.
Well, maybe they have RNA. Who knows?
Yeah, this one definitely got me thinking because George Lucas's plan, if he got to write his sequels, is he was going to dive even deeper into the fact that midichlorians were actually these microorganisms and that there was a living being inside of them called the wills, and that the wills we were just vessels for the wills. So
all right.
If George Lucas got his way, we were going to get really into the edge of life there.
Ooh, I would have liked that. Yeah. No, I mean, there's, science fiction, explores the edge of life in such a good way. Yeah. I mean, Star Trek had, Star Trek addressed the question of whether life has to be based on carbon. They had a silicon-based thing called the Horta, and this is like in 1960, this is the year I was born, I think, 1966, like a long time ago. Yeah. So it's you can play around in science fiction sometimes better than in other genres.
Absolutely. And you already called out one of the great ones in the book, talking about Mary Shelley's Frankenstein. So you already got that one in there.
The primordial science fiction classic. Yeah.
Yeah. All right. Question number 2. RNA makes up how much of the total weight of a human cell? Is it A, 5%, B, 10%, or C, 25%?
Ooh, this is interesting. I'm going to totally guess on this. I'm going to say 5%. But because I think a little can go a long way.
You are absolutely correct. 5%. And my research tells me that DNA makes up about 1% of the weight of the whole cell. So you're right. It does do a lot with a little. And then question 3, RNA technology is used in food science to make fruit. Is it A, taste sweeter, B, become juicier, or C, stay ripe longer?
Wow. I'm going to say stay ripe longer.
Absolutely correct. Yeah, stay on the vine longer too. Stay ripe on the vine longer. And I'm sure if we Googled it, RNA is probably used in food science to do a lot of crazy things, but that's the one I came up with. So, all right, not bad. Great job on the quiz there.
Woo! I see that our other watchers and listeners have been keeping up and answering it as well, which is pretty exciting.
Cool. Yeah, no, I've long been a big fan of RNA. Life probably began on Earth as RNA instead of DNA. People just sort of, learn about RNA maybe in high school and then probably forget about it. But I think now that like millions and millions and millions of people have gotten like RNA jammed in their arm and that's protecting them from COVID. Like, I think that's like people, you don't need to like sort of, sort of make apologies for referring to RNA and say like, oh yeah, RNA, such and such and such. Everyone's like, oh yeah, RNA,
Oh yeah, I know what that is now.
It's great. So yeah, I'm glad people are warming up to RNA as well.
Yeah, warming up their arms to RNA, actually.
Yeah.
This has been so wonderful. I know we're wrapping up our hour again, everybody. It always goes so fast. Carl, this has been fabulous to have you on. I know everyone's really appreciated it. Davey, that was a great quiz. And I want to put up a few reminders for you folks. You can get the book Life's Edge. Obviously, many of you have already picked it up, but you should get it. It's great in audiobook as well. I like to have both myself. Sometimes it's nice to listen as well as look. And here's a link in the chat. You guys can follow it right there. I also just want to remind you that we always have 2 a month, and next month we're actually having a double header as our first one. We're doing Wendy Moore at 6 UK time, 6 our time for the UK folks. And then at 7, we have Chuck Wendig talking about science fiction and Book of Accidents. We also are going to have Sam Keen on in August. So don't forget to tune in. If you haven't signed up for our mailing list, please do. Join our Facebook page. And am I missing anything, Davey? I always feel like I hate letting you guys go.
I know. Just to let you know a little of the technical side of how it's going to work next time we meet for our doubleheader. It is going to be 2 separate streams. It's going to be 2 separate YouTube streams. That way they can live on YouTube kind of independently and be their own conversation. So we all will have to jump out of the first conversation and jump into the second one, but I think we can all handle it.
Yes, and of course, Abby says support local bookstores. Absolutely. Thanks to everyone for being here. It was a great discussion. I really appreciate everybody and all of you. Big hugs to all the peculiars. Come back and join us again soon.
You got the blue bottle blues when you wake up in the night. Don't make a big mistake, 'cause you can never make it right. When you reach out for the vial, feel the ridges in the glass. It's a matter of survival, baby, better watch your back. There is no antidote. There is